Hey everyone. So as we begin our study of triangle congruence, right, we're coming off of talking a lot about rigid transformations. So as we kind of transition from talking about rigid transformations to talking about congruence and congruent statements as they relate to triangles, I want to go over a few examples that you have seen to just be sure that you are getting them correct and that you're understanding what the expectation is and what you're supposed to be doing. So here's our first problem that we went through. When a shape is translated, reflected, or rotated, the image is congruent to the pre-image, right? So if you remember, image is like is the new one, I guess is the word for it, right? So this is the after a rigid transformation. And the pre-image is the old one, right? So it's the original one that you start with. And if we're dealing with a triangle, maybe I had triangle ABC, and now my image is triangle A prime, B prime, C prime is how we would notate that. So hopefully that rings a bell. So when a shape is translated, right, these are our three rigid transformations: translation, reflection, and rotation. The image is congruent to the pre-image because it underwent, I don't know if that's a word, a rigid transformation. Right? So as simple as that. And it is rigid, it means that it maintains in shape and size. So if it underwent a rigid transformation, so it maintains its shape and size. Therefore, it has to be congruent, right? So just as simple as that. Let's keep moving. Oh my gosh. So in this one right here, it says to mark the triangle to show that AB, and this indicates segment, maybe you remember that, segment AB is congruent to segment DE. So I'm going to mark them off. So when we're talking about triangle congruence or just congruence in general, when we say that word mark, it just means you do this. Right? And so on the other end of that, if you saw these marks, they tell us that AB is congruent to DE. Having some technical difficulties. There we go. Okay, so now, same thing. Mark the triangles to show that angle APB, remember that middle letter is our vertex, is congruent, it's a V, to triangle EPK, right? So P is our vertex. So let's follow this along. APB, well, this is how I'm going to mark it. EPK. So those two angles are congruent. Did you know that I didn't even actually need to know this, right? If I just gave you this picture and said, hey guys, mark what's congruent, that's what you would have come up with. Maybe you know something called vertical angles, or we talked about those, right? Those are actually vertical angles. They're formed by two intersecting lines. They share a vertex. They're not adjacent, right? They're formed by they're opposite angles that are formed by intersecting lines. And vertical angles are always congruent. So I actually didn't even need to tell you this. It's one of those things I spelled congruent wrong. You would recognize without even being told it. How neat is that? Okay. So this is also a really important piece to know. It's like is it included or is it excluded? Is it included in them or is it not included, which is excluded? So name. So I'm not marking anything. I'm going to mark it also so that we know what I'm talking about, or you all know what I'm talking about. Name the side that is in between, right? Another word for that might be included, in angle A and angle C. So here's angle A, here's angle C, right? So if it's included, it's in both of them. So if I were to highlight angle A, right? Here's angle A. These are the two rays that formed it. And then new color. I'm going to go ahead and highlight angle C. Well, which side am I highlighting twice? Which one is included in both of them? Maybe you recognize that it's this side, right? So the side that's included is side or segment AC, and this is how I would name it with the appropriate notation. Which side corresponds, so it's in the same position, to LN? Well, here's L, here's N. The order that you write order always matters, but the order that you're writing these triangle congruence statements in is the order that it corresponds to. So like L is in position 1, so it corresponds to J, right? So just that, well, JK. So LN corresponds with JK. In fact, because we know these triangles are congruent, we can even go a step further and say that those corresponding parts are congruent, which is something we get to a bit later, but it is good to think about now. Yeah, let's do a few more. I do want to make a note, even though I was able to say it there because I was given a triangle congruent statement, just because two things correspond does not mean that they are congruent, right? So this side right here, this 2 corresponds with this 4. It's in the same spot. But this is, maybe you know the word dilation, which is something we'll study marking period 2, right? So it's clearly not the same size. It's the same shape, right? So these two sides correspond. The 7 and the 14 correspond. They're not congruent, but that doesn't mean that they don't correspond. So those two words aren't interchangeable, and one doesn't imply the other, right? Just because something corresponds does not mean that we can say that they're congruent. So, which corresponding parts? Oh, I kind of just did this one. LMN and PON. Which corresponding parts are congruent? Whoa, what do we look for? Right? Angle LNM is congruent to angle ONP because why? They're vertical angles, and vertical angles are always congruent. They're congruent because watch what happens here. Let's say I'm just going to make up an angle measurement here. I'm just going to make it up. So let's say that this was 46 degrees. Maybe you notice that this right here is a line, and a line, these are a linear pair. A line adds, the angles that form a line will add to 180 degrees. They'll be supplementary. So I could actually go ahead and do 180 minus 46, and that would give me 134. So this would be 134 degrees. If I went a step further, which I'm obviously going to, and I looked at this right here, it's another line. So this angle and the 134 should add to 180, right? There's another line. So if I did a 180 minus 134, guess what I get? 46. Oh my goodness, it was the same thing I got over here, right? Because they're supplements to the same angle. It's what really is happening there. And then this would be 134. These are also vertical angles. These two. Pretty cool. Given the image below, what is triangle CBA congruent to? CBA, let's look at what it corresponds to. So C, I've got this marking on it. So I've got to start with triangle, don't forget your notation. F, B is actually my right angle, so E, and then A corresponds with D. So CBA is congruent to FED. You need to look at what parts correspond, right? I could take this picture away, and just having this statement, we should know that what C corresponds to, right? So the order, this isn't, if I wrote this down in a different order, I did it wrong. It has to be triangle FED. Okay, last two, I believe. Given CB bisects AB, bisect, that word right there means cut in half. Cut into 2 equal parts. We know nothing about the angles, right? Because if you bisect a segment, you get two segments. So CB is chopping AB in half. CD, sorry, is chopping AB in half. So I'm going to get these two parts as being congruent. D is actually what we refer to as the midpoint. Pretty cool, right? There's another vocab word. What can we conclude? The only thing we can directly conclude is that AD is congruent to BD. Right? That's by the definition of bisect. That's all we know. We don't know anything else. Right? I guess I could also say D is the midpoint of AB. I guess I could say that. If you said something like that, I think you know what you're doing. Just go a step further and think that we're working towards congruence. So we want to be able to make statements that are called congruent statements. Okay, let's take a look at our last one. Yeah. Ooh. Oh. EG, segment EG is, this means this upside down T indicates perpendicular. And perpendicular has to do with angles. It means that it forms a 90-degree angle, or what we also know is a right angle. Okay, so EG is perpendicular to DF. We don't know anything about where it hits it. We just know that when it hits it, it's a right angle. Right, so I've got these two right angles. So I know angle EGD, I need three letters. And if I said angle G, you'd got no idea what I was talking about. EGF are right angles. Right? That's really the direct conclusion that I can make there. Right? I could go a step further, and after I know that they're right angles, I actually know that they're congruent. EGD is congruent to angle EGF because all right angles are congruent. But realistically, all I know right now, directly from this statement of perpendicular, is that they're both right angles. Be careful. There are things that are called perpendicular bisectors. There's no symbol for that. This just means to us perpendicular. The only thing we know from this symbol is that 90-degree angle. So hopefully this was somewhat helpful to go through some of this vocab and this beginning of triangle congruence as we transition from rigid motion to applying that to really get a solid understanding of triangle congruence and congruent statements. So thanks everyone for watching, and I will see you all next time.